Good morning, students. Myself, Dr. Vishwanath CC, Assistant Professor, Department of Chemistry, JSS Arts, Science and Commerce, Degree College, Gokak. This college is affiliated to Rani Chennamma University, Belagavi. In previous video, we studied simple collision theory and also we studied limitations of a simple collision theory. Today, we will discuss transition state theory. It is also called absolute reaction rate theory, and it is also called activated complex theory. This theory was developed by two scientists. First scientist name is Henry Eyring and another scientist name is Michael Polanyi in 1935. According to this theory, the reactant molecules, which is in initial state, which move from initial state to transition state, that intermediate transition state or activated complex, which is unstable, then it decomposes into products, that is final state, which is stable, is called transition state. According to this theory, the reactant molecules move from initial reactants state to the intermediate transition state or activated complex, which is unstable, and then it decomposes to the products state, which is stable, is called transition state. Next, when two reacting molecules approach each other, there is a continuous series of changes in bond distance. Here, when two reactant molecules approach each other or collide with each other, there is a changes in bond distance. Next, reacting molecules collide with each other and then converted into energy-rich intermediate molecules. Here, when two reactant molecules collide with each other, then there is a formation of intermediate molecule or activated complex which energy is rich. For example, when H2 molecule collide with I2 molecule, there is a formation of intermediate or activated complex. In that intermediate, there is a formation of weak bonds or partial bonds between hydrogen atoms and iodine atoms. After that, there is a breaking of bonds to form a new bond between hydrogen and iodine atoms to form two molecules of hydrogen iodide. This intermediate will exist very short time. Next, if reaction is unimolecular, the resultant molecule may produce activated complex by rearrangement of atom and redistribution of energy. Here, in the reaction having a single molecule and then it is converted into activated complex by rearrangement of atom and redistribution of energy. Next, activated reactant molecules has transient existence and remain in equilibrium with reactants and having maximum potential energy, then it decomposes to give stable products. Here, A is the reactant molecule and B is the another reactant molecule. When these two molecules collide with each other, there is a formation of activated complex, that AB star. This activated complex will remains equilibrium with the reactant molecule, that is A and B. This activated complex having maximum potential energy, then it decomposes into products which give stable products. Next, the rate of reaction depends upon two factors, namely, first one is the concentration of activated complex, second one is frequency of decomposition of activated complex. Here, the rate of reaction will be depends upon two factors. First one is the concentration of activated complex and frequency of decomposition of activated complex. Next, in the case of an endothermic reaction, this is the energy diagram of endothermic reaction. Here, the energy of reactants is low when compared to energy of products. Here, the reactants will absorbs energy from the surroundings and it is converted into transition state, then it decomposes into products. This products is less stable. Then overall a change in enthalpy, that is delta H, gives energy of products minus energy of reactants. Therefore, the change in enthalpy, that is delta H, is positive. This is the energy of endothermic reaction. In the case of endothermic reaction, the reactants are at a lower energy level compared to the products as shown in the energy diagram below. In other words, the products are less stable than the reactants. Overall, overall change in enthalpy, that is delta H, for the reaction is positive. That is, energy is absorbed from the surroundings. This is the energy of endothermic reaction. Next, in the case of exothermic reaction, the energy of reactants is high when compared to energy of products. Here, the reactants will absorbs energy and it is converted into transition state. Afterwards, the energy is decreases and forms of products. Here the energy released in the form of heat, then overall change in enthalpy, that is delta H, gives energy of products minus energy of reaction. Then delta H becomes negative. Here, in the case of exothermic reaction, the reactants are at a higher energy level as compared to the products as shown below in the energy diagram. In other words, the energy of products will be more stable than the reactants. The products are more stable than the reactants. Overall change in enthalpy, that is delta H, for the reaction is negative. That is, energy is released in the form of heat. This is the energy of exothermic reaction. Energy diagram of exothermic reaction. These are the postulates of transition state theory, absolute, it is also called absolute reaction rate theory, and it is also called activated complex theory. Thank you.